Imagine a world where physical objects are brought to life from digital blueprints. Welcome to the realm of 3D printing, a technology that has captured the imagination of innovators and creators alike. 3D printing, also known as additive manufacturing, has evolved from a niche technology to a transformative force across industries. This evolution is intricately tied to the development of 3D printing cartridges. These cartridges, containing the raw materials used in the printing process, have played a crucial role in expanding the possibilities of 3D printing. From the early days of rudimentary plastics to the advent of advanced materials like resins and metals, the journey of 3D printing cartridges mirrors the remarkable progress of the technology itself. And now, a new player has entered the scene: artificial intelligence. AI is poised to revolutionize the world of 3D printing, pushing the boundaries of what's possible and unlocking a new era of personalized, efficient, and sustainable manufacturing. The seeds of 3D printing were sown in the 1970s, a time of rapid technological advancement. Early pioneers experimented with different approaches to create three-dimensional objects from digital models. A pivotal moment arrived in 1984 when Charles Hull invented stereolithography. This groundbreaking technology used a UV laser to solidify liquid plastic resin layer by layer, forming a solid object. Hull's invention marked the birth of commercial 3D printing, opening up a world of possibilities for prototyping and design. In these early days, 3D printing was primarily confined to research labs and industrial settings. The technology was expensive, and material choices were limited. However, the potential of 3D printing was undeniable, and researchers continued to refine the technology and explore new applications. Before we continue, if you are enjoying this video, feel free to like, subscribe, and hit the notification bell to receive future updates. As 3D printing technology matured, so did the demand for more diverse and robust materials. Early 3D printers primarily used plastics, which limited their applications. Researchers and engineers recognized the need to expand the material palette to unlock the full potential of 3D printing. This quest for material diversity led to the development of new 3D printing technologies and corresponding cartridges. Selective laser sintering, or SLS, emerged as a method for fusing powdered materials like nylon and metals using a laser beam. Fused deposition modeling, or FDM, offered a versatile approach where a thermoplastic filament is heated and extruded through a nozzle, building objects layer by layer. These advancements opened up new possibilities for 3D printing, enabling the creation of stronger, more durable, and functional parts. The development of bioinks, printable materials containing living cells, further expanded the horizons of 3D printing, paving the way for applications in regenerative medicine and tissue engineering. The convergence of artificial intelligence and 3D printing has created a powerful synergy, propelling the technology into new realms of capability. AI, with its ability to analyze vast amounts of data and learn from patterns, is transforming every aspect of the 3D printing process. One of the key contributions of AI is in optimizing design for 3D printing. Traditional design methods often struggle to fully leverage the design freedom offered by 3D printing. AI algorithms, on the other hand, can analyze a design and suggest modifications that improve its printability, reduce material waste, and enhance its structural integrity. Moreover, AI is playing a crucial role in predicting and preventing printing errors. By analyzing data from sensors embedded in 3D printers, AI algorithms can detect subtle anomalies in the printing process that might indicate a potential failure. This early detection allows for corrective action to be taken, minimizing waste and ensuring the production of high-quality parts. Crafting perfection. AI-powered design. AI is revolutionizing the way we design for 3D printing, pushing the boundaries of creativity and functionality. AI-powered generative design tools are empowering engineers and designers to create complex, optimized designs that would be impossible to conceive using traditional methods. These tools work by taking a set of design constraints such as material properties, load requirements, and manufacturing limitations, and then exploring a vast design space to generate optimal solutions. The AI algorithms iterate through countless design variations, evaluating each one against the defined criteria. This iterative process allows AI to discover innovative and often unconventional design solutions that maximize performance while minimizing material usage. Generative design is particularly well suited for creating lightweight, high-strength components for industries like aerospace and automotive, where material efficiency and performance are paramount. Material evolution, AI's alchemy. AI is not only optimizing the design and printing process but also accelerating the development of entirely new 3D printing materials. Material scientists are leveraging AI algorithms to analyze vast datasets of material properties and discover hidden relationships between material composition, processing parameters, and final characteristics. This data-driven approach to material discovery is significantly faster and more efficient than traditional trial-and-error methods. AI algorithms can predict the properties of new materials with a high degree of accuracy, enabling scientists to focus their experimental efforts on the most promising candidates. This AI-driven material development is leading to the creation of 3D printing materials with unprecedented properties, such as super-strong composites, flexible and conductive materials, and biocompatible materials for medical implants. The ability to precisely tailor material properties at the molecular level opens up exciting possibilities for creating 3D printed objects with specific functionalities. The Intelligent Factory, AI in manufacturing. The transformative impact of AI extends beyond design and material science into the heart of 3D printing manufacturing. AI-powered quality control systems are becoming increasingly sophisticated, ensuring that every 3D printed part meets the highest quality standards. These systems use computer vision and machine learning algorithms to inspect 3D printed parts in real time, identifying even the slightest defects or deviations from the intended design. This automated quality control eliminates the need for manual inspection, which is time-consuming and prone to human error. Furthermore, AI is enabling predictive maintenance for 3D printers, reducing downtime and ensuring optimal performance. By analyzing data from sensors monitoring various printer components, AI algorithms can predict when maintenance is required, preventing costly breakdowns and production delays. This proactive approach to maintenance ensures that 3D printers operate at peak efficiency, maximizing productivity and reducing operating costs. A glimpse into the future. Personalized and sustainable 3D printing. The future of 3D printing is brimming with possibilities, driven by the relentless pace of innovation in AI and material science. One of the most exciting prospects is the advent of personalized 3D printing. Imagine a world where you can design and print customized products, from personalized footwear to tailor-made medical devices, all from the comfort of your home. AI will play a crucial role in making this vision a reality, empowering individuals with user-friendly design tools and automated printing processes. On-demand material creation is another exciting frontier. Imagine a future where 3D printers can synthesize the materials they need on demand, eliminating the need for pre-manufactured cartridges. This would revolutionize material sourcing and reduce waste in the 3D printing process. Sustainability is a key driver of innovation in 3D printing. AI-powered closed-loop recycling systems are being developed to recycle waste materials from the 3D printing process, minimizing environmental impact and promoting a circular economy. AI unlocks the full potential of 3D printing. The journey of 3D printing from its humble beginnings to its current trajectory is a testament to human ingenuity and the transformative power of technology. AI, with its ability to analyze vast amounts of data, learn from patterns and make intelligent decisions, is unlocking the full potential of 3D printing. As AI continues to evolve, we can expect to see even more groundbreaking advancements in 3D printing technology, materials, and applications. The future holds immense promise for personalized, on-demand, and sustainable manufacturing, powered by the synergistic relationship between human creativity and artificial intelligence. Thank you for watching. If you enjoyed this video, feel free to like, subscribe, and hit the notification bell to receive future updates.